There are 5 cards, each labeled with a different number from the set 1, 2, 3, 4, 5. The cards are randomly arranged in a row to form a 5-digit number. What is the probability that the 5-digit number is divisible by either 5 or 2? Okay, so the cases we're looking for are, if we were to show the set of all the numbers that are divisible by 5 and all the numbers that are divisible by 2, then we want both of those sets together, okay, and including any numbers that are divisible by both, okay. So it's just divisible. It qualifies as a one of our numbers if it's divisible by 5, it's divisible by 2, or it's divisible by both. Okay. So probability is just how many out of how many. So it's the number of desired outcomes. Okay, and like I said before, desired outcomes would be where it's divisible by 5 or 2 over the total number of outcomes, right? So total outcomes. All right, and if we just take the ratio of those two things, then we get our answer. So the total outcomes is fairly easy to calculate because we have 5 cards and we would have 5 choices to put down for the first number in our 5-digit number, and then we'd have 4 cards left, and then we'd have 3 cards left after we place the second card. We'd have 2 cards left, and then finally we'd have 1 card left, and that, if we multiply all those things together, we would get the total number of ways that we can arrange these 5 cards. Okay, so let's see, what does that give us? It gives us essentially 5 times, I'm going to write it as 5 times 4 factorial. I'm not going to calculate it out. I could. 5 times 24, so that's the same as 10 times 12 is 120, so that's equal to 120. But you'll see later, sometimes you don't have to go through all that multiplication because we've got a ratio of numbers and we want it in lowest terms. So we want to get rid of common factors. So it's not always necessary to multiply things like this all out. Alright, so let's look at our desired outcomes. Let's look at, first of all, what does a number look like if it's divisible by 2? Okay, so we're going to divide it into 2 cases. Let's look at the numbers divisible by 2, numbers divisible by 5, and then we'll look at the numbers that are divisible by both, make sure we haven't double counted anything. Alright, so we have 5 digits in this number, and the thing that's going to determine whether it's divisible by 2 is this last number. If this is even, then it's going to be divisible by 2. So how many even numbers do we have? We only have 2 and 4. Those are our only even numbers. So we only have 2 choices for the digits to put in this last place value. And then beyond that, we don't really care what order the numbers are in. So we have 4 choices for the first digit, 3 for the second, 2 for the third, and then we have 1 card left. We'll put it there. Alright, so we end up with, I'm just going to write this as 2 times 4 factorial. Okay? See how I've got this common factor of 4 factorial, which will come in handy later. Alright, so let's look at look at the numbers divisible by 5. Alright, we got 5 digits. And if it's divisible by 5, it has to end in a 0 and a 5. 0 or a 5, sorry. And you can see we don't have any zeros up here. So this digit has to be a 5. Alright, so we only have 1 choice for that digit. And then we don't really care how the other ones are arranged, because whatever, no matter how the other digits are arranged, it's going to be divisible by 5 if it ends in 5. So here we just have 1 times 4 factorial. Okay? And those are our 2 cases. Now, are there any cases where that we've overcounted, that we double counted, that were divisible by 2 and 5. Well, that's just divisible by 10. So it would have to end in 0, but we don't have any zeros, so in this case we don't have any. There's nothing in this intersection, okay? The numbers are either divisible by 2 or they're divisible by 5. But you do have to be careful about checking for that, because oftentimes you do have something in this overlapping set. Okay, so let's add up our two cases. We have 3 times 4 factorial, right? Again, I'm not multiplying it all out, because when I calculate our probability, I need the total number of desired outcomes. So that's 3 times 4 factorial. Alright, so that's 2 4 factorials plus 1 more 4 factorial gives us 3 4 factorials. And then the total number of outcomes without any restrictions is just 5 times 4 factorial. Okay? So you can see this 4 factorial term just cancels out. So it sort of illustrates the kind of the advantage with probability problems of not having to calculate the numbers all out. So we're left with 3/5. So that's our answer, 3/5. Or you could write that as 60%, right? So that's 6 over 10 or 60 over 100. So the other possible answer would be 60%.